Okay, we are back again. So this equation, how you got P bar, right? So it is actually this is, we have taken that T base is equal to 1 upon omega base, right? That is your omega base. Now question is P actually is equal to your d by dt, and 1 upon omega base is there. That means, let me clear it, that means this equation I can write like this. This equation I can write like this is equal to your T base instead of 1 upon omega base. Only this term, later you will know everything is okay. This is P, then psi d bar, only this term I am writing, right? Now P is equal to d dt, therefore this term can be written as your d by your, it is d dt, so it can be written by dt divided by T base, right? So that is your this term, right? So if you write like this, then this term will become d by dt bar, right? Because dt upon T base, so that can be written as actually P bar, right? So if you want to represent the time in per unit, that's why this equation, this T base is chosen. Ed bar is equal to P bar psi d bar minus psi q bar omega r minus R a bar I d bar. These are all per unit values. Bar means per unit values, but throughout our analysis we will only study for your what you call in time in second, right? But this is some representation in time in per unit. So equation 70 and 85, compare equation 70 and equation 85, you will see that the form of the original equation is unchanged only when all quantities involved expressed in per unit. So this here equation 70 also, there also Ed is equal to P psi d minus psi q omega r minus R a I d. In per unit also it is like that, right? So ultimately equation is unchanged, only there here 70 you have to put the you have to consider all the real exact values, and here they are dimensionless, that's all. Otherwise expressions will remain same, right? Similarly the per unit forms of equation 71 and 72 easily similar way you can do this, similar way, right? So it will be eq bar will be P bar psi q bar plus psi d bar omega r bar minus R a bar I q bar. This is equation 86. Similarly E0 bar will be P bar psi 0 bar minus R a bar I 0 bar. This is 87. Bar means all are per unit values, but equation are unchanged, only they are in per unit values, right? So whatever I told you, the P bar, it is d by dt, so it is 1 upon omega base d by dt, so P by omega base, right? So this is whatever the way I showed you, that how it will be P bar. Next is per unit rotor voltage equations. Now from equation 50, your divide throughout by field, it is EFD base, that is your field voltage, field side, right, is equal to omega base into psi FD base is equal to ZFD base into IFD base. Same philosophy like stator, here also it is rotor, right? So the per unit field voltage equation may be written as same thing, both side you divide by EFD base left hand side, then the other terms you divide by omega base psi FD base and ZFD base your IFD base, the way we have done it for the stator, similar meaning, right? Then you will get EFD bar is equal to P bar psi FD bar plus RFD bar IFD bar. This is equation 89, similar way. Similarly, the per unit form of equation 51 and 52 will be, it will be 0 is equal to P bar psi k d bar. Actually nothing is changed, just making bar to represent unit dividing those quantities, and I k d bar, this is 90, and another one 0 is equal to P bar psi k q bar plus R k q bar I k q bar. This is equation 91, right? Therefore the above equations show the form of rotor circuit voltage equation. However, we have not yet developed a basis for the choice of the rotor base quantities, right? Because we have to make things reciprocal, but earlier we have seen it is not reciprocal, right? So stator flux linkage equations, using the basic relationship of psi s base is equal to Ls base Is base, right? The per unit forms of equations 64, 65 and 66 may be written as, so I mean using this relationship psi s base, actually in general we know psi is equal to Li, right? Flux linkage is equal to inductance in current in general. So psi s base is equal to Ls base Is base, and this is psi d bar. Same way you could divide and simplify, you will find it is minus LD bar ID bar plus LFD bar IFD bar plus LAKD bar IKD bar. This is equation 92. Similarly, psi q bar will be minus LQ bar IQ bar plus LAKQ bar IQ bar. This is 93, and psi 0 bar will be minus L0 bar I0 bar. This is equation 94, right. Now, where by definition LFD bar will be LAFD upon LS base into IFD base upon IS base. These are very simple thing, but I suggest that little bit you derive, right, little bit you derive, right. So, LFD bar will be actually LAFD upon LS base into IFD base upon IS base, right. Similarly, LAKD bar will become LAKD upon LS base into IKD base upon ISB. This is equation 96. Similarly, LAQ bar will be LAKQ upon LS base into IKQ base upon IS base, right. So, this is equation 97. Now, rotor flux linkage equation. Similarly, in per unit form of equation 67, 68 and 69, same way we will transform. Equation remains same, only everywhere bar is there, that means they are per unit. Therefore, psi FD bar will be LFFD bar IFD bar plus LFKD bar IKD bar minus LFDA bar ID bar. This is equation 98. Similarly, psi KD bar will be LKDF bar IFD bar plus LKKD bar IKD bar minus LKDA bar ID bar. This is equation 99. And similarly, psi KQ bar will be LKQ bar IKQ bar minus LKQA bar IQ bar. This is equation 100. So, all these things, this per unit system, later I will take your example also on per unit, you will, all calculations will be shown, you will find that things are quite easy, right. So, where by definition again we know that LFDA bar is equal to 3 by 2 LFD upon LFD base into IS base by IFD base. This is equation 101. Similarly, LFKD bar is equal to LFKD upon LFD base into IKD base upon IFD base, right. Similarly, LKDA bar is equal to 3 by 2 LAKD upon LKD base into IS base upon IKD base, right. Similarly, LKDF bar will be LFKD upon LKD base into IFD base upon IKD base. This is equation 104, right. Similarly, LKQA bar is equal to 3 by 2 LAKQ upon LKQ base into IS base upon IKQ base. Now, all these things your what you call, if we see that here LFDA bar is equal to 3 by 2 LFD base IS base upon IFD base, right. And just hold on, and if you see here LFD bar is equal to LAFD upon LS base IFD base upon IS base, right. And here your LFDA bar is 3 by 2 LAFD, here LFDA bar is multiplied by your 3 by 2 LFD upon LFD base IS base upon IFD base, right. So, similarly your LKQA bar also multiplied by 3 by 2, but we have to actually what we have to do is that we have to see that things are reciprocal. That means per unit values either referred to stator or rotor side have to be same, like transformer I refer to primary or secondary side, but one 3 by 2 factor is there, we have to eliminate that. So, the rotor circuit base quantities will be chosen so as to make the flux linkage equation simple by satisfying the following. The per unit mutual inductances between different windings are to be reciprocal. That is, for example, LAFD bar must be is equal to LFDA bar. This should be equal, right, per unit referred to either side. This will allow the synchronous machine model to be represented by equivalent circuit, right. So, for that second thing is that all per unit mutual inductances between stator and rotor circuit in each axis are to be equal. For example, LAFD bar is equal to LAKD bar, right. In order to have LFKD bar is equal to LKDF bar, because it is your what you call, this is your, this has to be made reciprocal, so that reciprocity is achieved. From equation 102 and 104, it is necessary to have this relationship that LFKD upon LFD base into IKD base upon IFD base is equal to LFKD upon LKD base into IFD base upon IKD base. Just equation 102 and equation 104. If you do so, because this condition has to be met, otherwise it cannot be reciprocal, right. So in that case what will happen, this side is becoming LKD base into IKD base square is equal to LFD base into IFD base square, right. So just what you do is cross multiplication, right. So in this case, then that means multiplying both sides by omega, if you do omega base, then it will be omega base LKD base IKD square base is equal to omega base LFD base IFD square base, right. But we know that omega base, L base and I base is equal to nothing but the E base, right. This we know. Therefore this side we can write, left hand side it will be EKD base IKD base. From the dimension analysis of the per unit and this dimension, your what you call that, earlier we have seen this, right, from its dimension only, right. So it basically it will be EKD base IKD base, because it is IKD square is there, so naturally it will be EKD base is equal to your this thing, this base, this one, that is your, this is the general formula for the dimension thing as far as per unit thing. So instead of that we can write is EKD base IKD base, and this one right hand side will be EFD base IFD base. This condition has to be satisfied for the reciprocal thing, right. So only thing is that apparently it looks little difficult, but it is not difficult. If you face any question, if you face any problem, when you will go through this, you put the question in the forum, we will answer all the questions, right. And all the, at that time if you want, if you fail to derive one or two things, you will try to provide you the your what you call the derivation, but I didn't bring it here, it will kill lot of time, right. But you have to keep this mind only, keep it in your memory only, right. Therefore in order to, for the rotor circuit mutual inductances to be equal, their volt ampere base must be equal, because this side is volt ampere V into I, basically E into I, this side is also E into I, so volt ampere base must be equal, right. Similarly for mutual inductances, that is LFD bar and LFDA bar to be equal, from equation 95 and 101 they have to be equal, otherwise you cannot make per unit and refer to either side is equal, you have to make this condition, right. So if you do so, then we are making LFD upon IS base into IFD base upon IS base is equal to 3 by 2 LFD upon LFD base into IS base upon IFD base, and you cross multiply and simplify, it will be LFD base into IFD base square is equal to 3 by 2 LS base into IS base square, right. So both sides you multiply by omega base. If you multiply both sides by omega base, and same as before, you will find that this side you multiply both sides by omega base, then omega base LFD base and it is IFD square, so into IFD base into IFD base. So first three terms will give you actually EFD base. So it will be EFD base into IFD base. Similarly the right hand side it will be 3 by 2 ES base into IS base. I mean it is something like this. I mean both side you multiply by omega base, then left hand side only I am writing, right hand side similarly you can get it, it is omega base, then LFD base, then IFD base, right. It is IFD base square, so into your IFD base. So this term is nothing but EFD base into IFD base. Similarly the right hand side same meaning, right. So the right hand side also you can write that your 3 by 2 then ES base into IS base. Now this one you can write 3 and 2, this 2 is there, you can write ES base upon root 2 into IS base upon root 2, this is equation 108, or you can write it is basically 3 into, it is 3 phase volt ampere base for the stator. This is basically ERMS and this is basically IRMS. We have taken earlier, that your ERMS is equal to ES upon root 2. Similarly your IRMS is equal to IS base by root 2, right. That is actually nothing but 3 into ERMS into IRMS, that is nothing but 3 phase volt ampere base for the stator, right. Similarly we have to make this thing LAKD bar is equal to LKDA bar and LAKQ bar is equal to LKQA bar, because we want everything should be in reciprocal, right. So the similar way you can make it EKD base, if you equate this one and this one, you will get EKD base IKD base. Go back to those referred equation and just equate it, I didn't write it here. If you do it, it will be EKD base IKD base is equal to 3 by 2 ES base into Is base. Similarly, EKQ base you have to call into IKQ base is equal to 3 by 2 Es base Is base. This is equation 110, right. So, these equations imply that in order to satisfy requirement A above, the volt ampere base in all rotor circuits must be the same and equal to the stator 3-phase volt ampere base, right. This we have to make base quantities, right. I mean, this side is the right hand side is the stator base quantities and left hand side is the rotor side, right. They have to be made equal. So, stator leakage inductances in the two axes are nearly equal, right, denoting the leakage inductance LL bar and the mutual inductances by LAD bar and LAQ bar, right. Therefore, LD bar is equal to LL bar plus LAD bar, directly you can write, and LQ bar is equal to LL bar plus LEQ bar, directly you can write. This is 111, this is 112, right. In order to make all the per unit mutual inductances between the stator and rotor circuit in the dx is equal, your dx is equal, from equation 95 and your 96, it follows that you have to make everything is equal, because you have to make a per unit thing either rotor side or stator side, they should be equal. Therefore, LAD bar you can write LAD upon LS base is equal to, you have to equate it at LFD bar, that is also we have seen LFD upon LS base into IFD base upon IS base, or this can be equal to LAKD bar is equal to LAKD upon IS base into IKD base upon IS base, right. Similarly, your IFD base will be LAD upon LFD into IS base, and similarly your IKD base, from that one IKD base will be LAD upon LAKD into IS base. This is equation 114. Just my suggestion to all of you, when you will go through this course, every week notes, everything will be uploaded, but you please do it little bit of your own. If you stuck somewhere, you put the question in the forum immediately, we will solve your problem, right. But nothing is there actually. Initially, perhaps you may think that what things are, but just practice one or twice, you will find actually everything is easy. It is per unit system only. Power system analysis course, in your undergraduate course you have studied per unit, but index synchronous machine case for dynamic stability studies, this per unit representation is slightly different, right, although meaning is same. Similarly, for the Q axis mutual inductances LAQ bar and LAKQ bar to be equal. So, in that case we can write same as before, IKQ base is equal to LAKQ by LAQ by LAKQ into IS base. This is equation 115, right. This completes the choice of the rotor base quantities, right. So, as stated before, the per unit system used here is referred to as the LAD base, reciprocal per unit system. In this system, the base current in any rotor circuit is defined as that which induces in each phase a per unit voltage equal to per unit LAD bar, that is the same voltage as balanced 3-phase unit, your 3-phase unit peak armature currents, right. So, this is what you call, that is your per unit system. So, things are actually, my experience shows over the years, this per unit system initially student they have, I will take example also. Student may feel initially that things are difficult, but it is not at all difficult. Just to derive one or twice, you will find actually the way you have done per unit analysis for power system courses in undergraduate studies, it is the same thing, only the representation is slightly different, right, because of your DQ transformation, right. So, you should practice, and if you have any problem, then you this thing. I have over the years I have experience on this. Initially maybe little bit of problem, but after that when you will go through it, you will find things are quite easy, right. Now, per unit power and torque, here also that we have derived this equation from equation 73, that PT is equal to 3 by 2 EDID plus EQIQ plus 2 E0I0. So, dividing by the base 3-phase volt ampere both sides, that is 3 by 2 ES base IS base. If you do so, it will both sides you divide by 3 by 2 ES base. So, this side it will be per unit, left hand side 3 by 2 will be cancelled, right hand side, then it will become ED upon ES base into ID upon IS base, EQ upon ES base into IQ upon IS base, it will be 2 into E0 upon ES base into your I0 upon IS base. So, this is actually writing PT bar is equal to ED bar ID bar plus EQ bar IQ bar plus 2 E0 bar I0 bar, they are in per unit. I mean, it is like this, because we know this, dividing by your, because it is power, so 3 phase volt ampere of both sides. If you divide this one left hand side, right, it will be your PT bar, it will become actually PT bar, that is PT upon 3 by 2 ES base IS. Now right hand side if you do so, 3 by 2 will be cancelled, ES base IS base, first term will be your ED by ES base into your ID upon IS base, right. So this term actually nothing but your ED bar, and this term is nothing but your ID bar. Similarly, this term also EQ upon ES base will be ES bar, EQ bar, and IQ upon IS base will be IQ bar. Similarly, 2 into E0 upon ES base will become E0 bar, and I0 upon IS base will become I0 bar, because we are representing things are in per unit. So that's why this equation is written as your PT bar is equal to, only expression remains same, only things are per unit values, right, and all numericals other things from real value to per unit value transformation we will see, and all numericals we will do in per unit values, right. So PT bar is equal to ED bar ID bar plus EQ bar IQ bar plus 2 E0 I0, this is 116. Similarly, with the base quantities, with base torque, that is 3 by 2 PF by 2 psi S base IS base, this also we have seen. So per unit form of equation 75, now you divide that your equation 75 by this one, you will simply get T bar will be psi D bar IQ bar minus psi Q bar ID bar, same as before, it will come psi D upon psi S base and it will become your IQ upon IS base, so all will be bar. Similarly for psi Q upon psi S base, and this term will become ID upon IS base, so all are bar per unit, everything remains same, all are per unit, right, and this is your equation 117. Now per unit reactances, if the frequency of the stator quantities is equal to the base frequency, the per unit reactance of a winding is numerically equal to the per unit inductance, right. Sometimes in the numericals we tell per unit reactance, it can be taken as per unit inductance also. For example, XD is equal to say 2 pi f LD ohm, right, because dividing ZS base, because ZS base is my impedance base, and that is nothing but 2 pi f base into LS base, right, is omega is equal to your, that is ZS base, ZS base is nothing, Z is equal to L omega, so omega base will be 2 pi f base into LS base. Now if you divide both sides XD upon ZS base, so it is 2 pi f upon 2 pi f base into LD upon LS base, right, but f is equal to f base, right, per unit values of XD and LD actually are equal, because f is equal to f base, because f base your synchronous machine rotating at a say your synchronous speed, and f base is nothing but if it is 60 Hz it will be 60 Hz, if it is 50 Hz it will be 50 Hz. So f is equal to f base, that this term will be cancelled, 2 pi f is equal to f base and this is 2 pi f base, ultimately it will become XD per unit is equal to LD per unit. So in per unit, whenever say per unit reactance means it is per unit your inductance also, right. So for this reason in the literature, as your what you call on synchronous machines, symbols associated with reactances are often used to denote per unit inductance, right. So numerically if it is given per unit reactance, then it is per unit inductance also. If it is given per unit inductance means it is per unit reactance also, right. So with this, your what you call this per unit, this is now summary of this your per unit equation, right. So base quantities, now stator base quantities, 3 phase volt ampere base is equal to volt ampere rating of machine, volt ampere, ES base is equal to peak phase to neutral, your what you call peak phase to neutral rated voltage in volt. So whatever we have studied, the summary, I have made a summary for you. F base is equal to rated frequency in Hertz, IS base is equal to peak line current ampere, that is 3 phase volt ampere base divided by 3 by 2 ES base, right. Similarly, ZS base is equal to ES base upon IS base ohm, right. Omega base is equal to 2 pi f base, that is electrical radian per second, right, and omega m base is equal to omega base into 2 by pf, that is mechanical radian per second. Then LS base will be ZS base upon omega base, this is in Henry, and psi S base will be LS base into IS base, that is Weber turns, right. So next, rotor based quantities. This is a summary. So IFD base will be LAD upon LFD into IS base ampere. This will help you to solve numericals, right? IKD base will be LAD upon LAKD IS base ampere. IKQ base will be LAQ upon LAKQ IS base ampere. EFD base will be 3 phase volt ampere base upon IFD base. This is in volt, right? ZFD base is equal to EFD base upon IFD base. This is ohm, right? Is equal to 3 phase volt ampere divided by IFD square base, right? So this is a summary. And ZKD base is equal to 3 phase volt ampere base upon IKD square base. This is ohm, right? ZKQ base is equal to 3 phase volt ampere base upon IKQ square base. So this is your ohm, right? LFD base is equal to ZFD base upon omega base. This is Henry. Then LKD base is equal to ZKD base upon omega base. This is also Henry. LKQ base is equal to ZKQ base upon omega base. This is also Henry. T base 1 upon omega base. This is second, right? And therefore T base is equal to nothing, 3 phase volt ampere, that is torque. This is multi time. This is torque base is equal to 3 phase volt ampere base upon omega mechanical base. This is Newton meter, right? Complete set of electrical equations will be seen in the next lecture. So thank you very much. We will be back.